That's a good way to start a video. Clear your throat. All right, so Daniel just said, did we go through Go routines? And I was like, no. And you see there's a folder here, Go routines, but there's like a big chunk in the middle that wasn't completely fleshed out, and we just sort of like, and Go routines was a big part of that. So, there's a little bit of things that are a little bit rough, but I kind of think also that when you look at this stuff, you'll start to get some of the things in the back. We're going to see some of that today, some Go routines. So today we're going to talk about TCP servers, and that's going to include talking about package bufio and scanners, and it's going to talk about package strings and fields, and then we're also going to see some concurrency. But first, a review. And present. So we were looking at doing a TCP server, and we were doing that with package net, and so we could use like net.listen, or we did net.dial to dial in with a piece of software, and and then we could accept it and it'd give us a connection, and connection's a reader and a writer. But I always like to just come back to like, hey, as much as possible, let's try to look at this stuff and see if we can understand things from the docs. So just a little bit of a story I think I shared with you on Tuesday, that, because I went to this training, the guy who did the training knows the product manager of Go at Google. Like, wow, you're the product manager of Go at Google. And then he talked to that guy, and that guy was like, hey, I'd love to talk to you about how you're teaching this in class. So I had a conversation with Jason at Google, the product manager of Go. Like, stranger than fiction, weirder things have happened, right? But here I am talking to the guy who like is basically in charge of growing the Go programming language. He's in charge of the Go programming language. And he even said in the conversation, it's like, usually a product manager will tell the engineers what to build, but I can't tell those guys what to do because they're so much smarter than me. He's like, I'm a super smart guy. I did great in school. I could code all day, and I feel like those guys are like, wow, that's the difference between somebody who's like in the major leagues and can just crank home runs, and somebody who's like playing minors, he didn't say this, but I think the inference was, he's in the minors, and those dudes like are heavy duty, hardcore major league baseball players, so to speak, right? The analogy. But anyhow, so one of the things we talked about, he's like, what's it like teaching it? And so we talked about that, and he said, yeah, that's one of the challenges is that the guys who created this, Rob Pike, Ken Thompson, Robert Gressmer, are so brilliant, that it just seems totally stupid, dumb, basic to them and completely obvious, and why don't people get it, And so the documentation can sometimes, be difficult to go through, but I think it's good to, as much as possible, look at it and try to piece things together, looking at it from the theory. Another thing Jason said is like 10% of people can look at the code and know how, or look at the docs, the spec, and know how to use it. Right, like, oh, I see the spec, I totally know how to do that. They learn through theory. Like, here's the theory of the different pieces, and they can just put it together. The other 90% of people have to learn through example. I fall into that 90% category, right? And so one of the takeaways of our conversation yesterday was like, he's going to take this back to those guys that, hey, we'd like to see more examples in the docs. Like, how do you actually apply this stuff? How do you put the pieces together? All right, so that said, we were talking about the package net, and we're laying the foundation for how do we do HTTP stuff? Because HTTP in the network layer sits on top of TCP, right? And so we're starting out at the TCP layer, and there's layers down beneath that, like the actual physical layer and everything like that. And we're not concerned about that. One of the things Caleb talked about in the training was that the layers that are down there, you just have to assume that works. Like, to be a programmer is just to make assumptions that things are going to work. And if it doesn't work, then you have to go fix it. Like, you will never have complete, thorough knowledge of any system you ever built. Any system you ever build is going to rest upon things other people have already built. Because for you to understand everything, you'd have to understand, like, cables, the physical layer, TCP, like everything, and that's just impossible. So at a certain point, you just have to say, okay, I got this thing working good enough. I thought that was an interesting thing. It was actually reassuring to me. It's like, oh, good, because I don't know everything, nor do I think I could ever wrap my head around everything. So you pick up what you can do, and you build what you can build. So here's the package net, and package net provides a portable interface for network I/O input-output, including TCP/IP, UDP, domain name resolution, and Unix domain sockets. So we have the dial function and we have the listen function. And then we do have a couple examples here like net.dial, where a piece of software is able to dial in as a client. We were also able just to dial in as a client using telnet, but here's a piece of software that's dialing into some location, you know. And then here we did the listen one, net.listen. So other thing I just want to say is, like, I'm working really hard, really hard. Like, this is the hardest I've ever worked to teach and learn something. Like, last night I went to bed at 3:45 prepping. Like, on Tuesday, I didn't sleep Monday night, right? Like, I prepped till 7 a.m. and then my family was up. And I was like, okay, time to go to work. And I called Eunice up and I was like, dude, I need you to drive. I can't drive. I'm not safe. Like, I'm that sleep deprived. But I don't know why I'm telling you that. Anyhow, so I guess because like Tuesday I was a little bit low energy, and I got more game today because I actually got like 4.5 hours of sleep. So I'm totally charged, man. I'm ever ready now. 4.5 hours sleep, watch out, it's coming. I'll slow down a little bit. You're like, yeah, you also drank too much caffeine, Todd. All right, here we go. So, you know, the thing that's interesting to me is just to look at the language, right? PackageNet provides a portable interface for network I/O. So I understand all of that sentence, except portable. Like, why did they include the word portable? You know, and so those kinds of questions for me are interesting because I ask those, but then later I'll actually find an answer to that. I haven't found an answer to this one yet. Daniel probably knows. Let's hear it. Let's find the answer.
It's because Windows, Mac, and Linux all have different ways of accessing their networking stuff. So it's portable in that you can use the same code on all platforms.
Thank you, Stack. That's awesome. That makes sense. All right, so what will this code do? Question for you. Get your minds engaged. Yeah, it's kind of funky on the board. Let me turn that. Hold on. Oh, that didn't do anything. Who wants to talk it through? Somebody else talk it through. Who wants to do it? Just walk us through it. You know where to start. Where do you start? Where do you start when you start reading this code? What's the first place your eye goes? I'm going to read this code. What do I start reading? At what point? Do I start at package main? Do I start at the imports? Do I start at func handle? Do I start at func main? Start at func main, right? And then the first line is net listen. Okay, we're setting up a listener, right? And we're listening on TCP and port 9000. And it gives us LI, a listener, and an error. And then if there's an error, you know, we just like log the fatal line that when whatever the error is. And then we defer the close, which means, okay, when main exits, last thing we're going to do, you know, before we leave this program is close down our listener. And then we do an eternal loop, always looping. So it's just like always checking, is there something to listen to, something to listen to, something. It sounds like insanity, but that's what the computer's doing, right? Just like some insane person. Is there something to listen to, something to listen to, something to listen to? Are the enemies outside my door? Are the enemies outside my door? Are the enemies outside my door? It's just listening, right? And then it's like, okay, I got something to listen to. I'm going to accept that, and it creates a connection. And then we're going to handle that connection. And handle isn't anything special. It's just a function we wrote. And the connection implements the reader-writer interface. Right? And so we pass into this function we wrote handle. Now we jump up to line 10, and we have a connection, and it's of type net.con, right? So that's what the type, that is its type. And if I ever say anything wrong, Daniel will say, no, that's not true, Todd. Okay, what did I get wrong? And then we defer connection close, right? So again, we're going to close this connection when we exit handle, and we do a scanner bufio new scanner con. Right? Okay, well that's interesting. We'll learn more about that in a second here. Bufio is the package, and then we do something new scanner, and we pass in the connection. So it looks like it takes a reader or a writer, because that's kind of like the general way we could pass things around. Like, you know, we talk about things accepting a reader-writer, and connection's a reader-writer. And so then we get a scanner, and then scanner scan, and it's like a range or something. We're looping here, for scanner scan. And so like maybe this is going to give us something where if we have many lines of text, it'll go over every line. Right? And then scanner text, give us that line, right, each time, and then we print that line. You know, so that's kind of cool. And some of the things when we look in the docs to tell us about that, right, is we've got the listen thing, and the listen returns a listener. So when we do a net listen, like we do right here, net listen, right? We see that, okay, it takes these arguments and it returns a listener and an error. And we got that, whoops, and we got that, come here, baby. We got that listener and the error. And then the listener, right, is a type with accept, close, and address, right? And so we have those two things, and we're doing accept right here, and then we're also doing the close right there because, okay, listen gives us a listener, and the listener has accept and close, so we use accept and close. And then we do handle, and we defer that, and then we do that scanner stuff. So this is what this does, right? So I go to the terminal, and I let's see here. I run my main program, and then I go to another terminal, and I log in through Telnet localhost 9000. I go to that connection, right? And when I'm at that connection, I could type hello, and it goes hello. And I type look at that over here, and the server picks up look at that, so it accepts that, right? And that's an interesting question. So, I accept my connection, I get my connection, I go to handle, I defer it, and then bufio, buff new scanner, I get my new scanner, and then my scanner here looks like it's eternally scanning. Is that just a loop there? So every time I write code, it's just going right to there. So hello comes in, and then we get that line and we print it. And then look at that comes in, and we get that line and print it. And then this line comes in from one client connection via Telnet, we get that line, and then we print it, and it prints down here. So that's how that's working.
Yep, scan returns false when there's been an error, including the end of connection error.
So that's just always listening right here. It's not like every time I type something new in, it launches a new connection, right?
No, that's correct.
Okay,
So,
cool.
yeah, scans
Just
are
make sure
sitting
my
there
understanding's
waiting
right.
Scans are sitting there waiting for more stuff to do stuff with.
Ah.
And then as soon as there's an error of some sort, including the benign error of the connection got closed, scan will return false instead, which ends the loop.
That's awesome. Mini minds. We will figure this out together. So there's that connection bit, right, where the connection's the reader and the writer, and there's the connection implementing the reader and the writer. And so let's take a look at package bufio, because we saw here bufio new scanner. Right, so let's just look at the documentation on that. And bufio implements buffered input-output. It wraps a reader and a writer object, creating another object that also implements the interface, provides buffering, and some help for textual input-output. So it provides buffering. So how did we use that? We used bufio new scanner, right? Scanner. So it wrapped a reader and a writer. So here we wrapped a reader and a writer because con is a reader and a writer. How many people this is like way too slow for you? Raise your hand. How many people this is way too fast for you? And you're like, okay, I'm kind of getting it. Raise your hand. How many people this is just right, like Goldilocks and Three Bears? Okay, cool. So, right, and so then we had bufio new scanner. And you can see here when we do new scanner, it takes a reader and gives us a pointer to a scanner. And if we have a pointer to a scanner, we have all these methods, right? So these are receivers here, and these are the method names. And so that's how we do a method. A method is just a function that has a receiver on it, which means it's now attached to this. What would you call that, an object?
Yeah, it's a struct.
This struct, there we go. And so we have these different methods we could do, like scan, split, text, air, bytes. And scanner, just some of the stuff here, provides a convenient interface for reading data such as a file of new line delimited lines of text. So, how many people have worked with scanners in other languages? That's pretty common. How many people have not? Okay, cool. So scanner provides convenient interface for reading data, such as a file of new line, delimited lines of text. What's a file of new line, delimited lines of text? What's that mean? New line, delimited lines of text. New line delimited. New line delimited. So that's just like a file with returns, right? And we got lines on the file. And so successive calls to the scan method will step through the tokens of a file, skipping the bytes between the tokens. Right? What are tokens? What are tokens in that context? Are tokens the delimiters, or are tokens the actual things we want to sort of read? Neither one? None of the above. What are tokens?
Should be what you want to come out.
Yeah. What I want to read. So if the delimiter was the new line, the token would be the text for each line, right? The specification of a token is defined by a split function of type splitfunc. The default split function breaks the input into lines with line termination stripped. Split functions are defined in this package for scanning a file into lines, bytes, UTF-encoded runes, and space-delimited words. The client might instead provide a custom split function. All right, so let's see that in action. So here's the example from the documentation, and in these examples in the documentation, you could click play, and it'll take you to the Go playground, and you could run the code. However, this code is asking for input from OS standard in, from the command line. So if you run this at the Go playground, right, just by clicking play, I don't have any way to add OS standard in, that I know of, right? And do you know of a way? Yeah. So I just brought this over here, and I'm showing you where it is in our GitHub stuff, so you could go take a look at it, right? But here, bufio, new scanner, OS standard in, so it's going to scan what's coming in from standard input. And if we look at new scanner, what does new scanner take? Ooh, I thought I had that here. Maybe it's afterwards. New scanner takes a reader and returns a pointer to a scanner, right? And so here, OS standard in must implement the reader interface. If this is taking a reader, that's got to implement the reader interface. So if we went and looked at that, we'd see, that read method there. And it returns a scanner, and then for scanner scan, print line scanner.text. This will print back, this will add back the final, that line character right there. So when I run this, I type, here's something I entered, and it just prints that back. Here's something I entered, and here's something more, and here's something more, right? So it's continually scanning standard in, and every time I enter a line, right, it gives me the text of that line and prints it. Anybody have any questions? Straightforward? So new scanner returns a new scanner to read from R, which is the reader. The split function defaults to scan lines, so it's going to basically use the line break as the delimiter, but we can change that, which we'll see in a second. And then this method, scan, right, and that's the receiver, pointer to a scanner, which is what we got, right? Scan advances the scanner to the next token, which will then be available through the bytes or text method. So scan just advances to the next line. So give me the first line, give me the next line, give me the next line, give me the next line, just loops over each of the lines. And every time it loops over the line, scanner text returns the most recent token generated by a call to scan as a newly allocated string holding its bytes. Right? So what that says is, hey, give me the text of that line. So give me that text of that line and print it. How many people that gives you clarity on that? You have clarity on that, how that works. How many people not so much still? All right, cool. So, it's just like a process of becoming familiar with, you learn a language, you got to learn the syntax, and then you got to learn the packages. And it's becoming familiar with the packages and how they work. And then you also have error, which returns the first end-of-file error that was encountered by the scanner. And I think the error is interesting the way this is implemented here, because you're not doing an error where it's like, hey, give me the value, and then an error, and then checked, was there an error, right? You do all this, and then you also, down here, have a check for the error. You have any thoughts on that, why they did it that way?
That looks like it may be a holdover from C, because that was a very common way of doing errors back in Unix when you're coding with C.
But so what happens, right here, this is where my control flow or whatever, right? The program just gets here and just keeps going there, right?
Yeah.
So if there's an error, it errors out of that and then goes to here?
Scan returns false as soon as there's an error.
Oh, so then that's, okay, so then it does pop out and it goes here, so it returns false as soon as there's an error. Cool. All right. So here's another example they have from the documentation, which again, I won't have you read it there. Because I brought it back into WebAdvisor to work with it here. WebAdvisor. What the heck did I just say? WebStorm. WebAdvisor is a whole other thing. That's something I have to enter grades on at City College. I brought it back into WebStorm here. And we have a constant, which is a string, right? And with constant, you don't use the colon equals, right? You just use equals. And then we have a scanner, new scanner, and strings, new reader, input. Well, a scanner takes a reader. And then we have a string right here, which is a constant, input. Well, this must be like some sort of a wrapper that takes a string and wraps it so that it is now a reader, right? Because this needed a reader. And when we look that up, we'll see that. So we get our new scanner, and it's scanning this string right here. And then we do a bufio scan words. So bufio scan words, bufio scan words. Huh, interesting, right? And then we do scanner split. So we said, hey, normally scanner will split on the new line character. That's the default. Now I want it to split on words. right? And to do that, I have to say scanner split on words, okay? And so that this is just like you know, that's another function in the bufio package. Needed a breath. Okay. So then we do count equals 0 for scan or scans. We're going to scan every token. We're going to add 1 to count, right? And then if there's an error, we're going to put out that error, and then we're going to produce the count. And the count is 15. So you see down here in the terminal, 15. So it counted all the words: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and it printed out all the words. So my question, and here is sort of that waterfall of like how everything's connected, right? Like a new reader up here at the top takes a string and gives you a pointer to a reader. New reader returns a new reader. Reading from S is similar to bytes new buffer string, but more efficient and read-only, right? And we needed to do that because we had a string and we needed it to be a reader so that new scanner could take it. Because new scanner, right, takes a reader and gives us a pointer to a scanner, and then a pointer to a scanner has split. And so split right here, right? Split will take split func, right? And so here is sets the split function for the scanner. Here is scan words, which we used right here, bufio scan words. And scan words splits a function for a scanner. So, you know, if I read that in the documentation, I'd be like, I don't know how you use that. That's where I'm like an example guy. It's like, okay, I don't learn from like the theory. It's like I got to see in action. Okay, you split, and then I tell it how I want it to split. That totally makes sense to me, all right?
And split func has got that the same. It's basically just a function of that signature, scan words, same arguments in, same return types.
Yeah, sometimes you say things, and I'm like 0, 1, 1, 1, 0, 1, 1. I'm like, I don't quite understand the machine language. Say that again.
So split func is it's just saying it's type split func here.
Yeah, and this is a split
So,
func.
and that's the scan just saying scan words is a split func. A split func is a function that takes in a slice of bytes and a bool and returns an int slice of bytes.
We got to look at that. Bang, bang, godoc.org/bufio. And we were looking at scanner split, which takes a split func. So we got scanner, and then we have split, and it takes a split func. And if we click on split func, a split func. Split func is a signature of the split function used to tokenize input, and the arguments are initial substring. But you know, the things it ends up taking are these things right here: words, lines, bytes, runes, right?
Yeah,
so how did I know from that thing that these are the split funcs? I wish they were just like, you know, hey, these are your split funcs.
Yeah. So yeah, you can tell it's the split func because the split func definition has got the same signature as those 4 functions.
Oh, right. So this right here, that's the signature right there.
Yep.
The
So yeah, its type
parameters.
split func is a function with those parameters.
A function with those parameters. Thank you, Stat.
So you can make your own too, but it's with those parameters it can be confusing.
That's cool. Yeah, because here we have data, slice of bytes, at EOF, bool, advanced int, token, slice of bytes, and we had data, slice of bytes, at EOF, bool, advanced int, token, slice of bytes, error. So those are the same signatures. Sweet. Learned something new. How many people learned something new? All right, cool. All right, so there's scan words, and then finally we just scan, which scan advances the scanner to the next token, which will be available through the bytes or text method. So you take that, what we just did. So this turns it into the new reader, right? New scanner takes a reader, and then we split, and we pass in a split func, and we know it's a split func because when you look up split funcs, they have that signature. Thank you, Daniel. And then we scan or scan, and it goes over all of our tokens like a loop, right? And we count each time, and then we print out the count. So here's the question for you. There's that. How would we change this code to print each word? And you're going to change line 18 and get rid of line 23. So what do you change in line 18? 23 is gone. Here, let me give you, let me see. Now you're like, I don't have anything to look at there, Todd. The answer's on this page. Which one of these do you use to print each word? Text, right? Text returns the most recent token. That's it. That's all you need to know, right? So let's look at that. Print line scanner text. And you can see that those words got printed over here. Are we awesome or what?
So,
Dude, we're going to figure out the hardest language, which is the simplest language, and the cleanest once you understand it.
so scan finds the next token, whether words, lines, whatever your scan func says, and then text gives you whatever it found. Because scan doesn't return whatever it found. Scan returns whether there's more defined or there was not.
Okay, I have a question. Is the normal delimiter new line or space?
It defaults to new line. So
Yeah.
this one is per word because you got scanner split on line 14.
I'm used to Python. I can just call split and I
Yeah,
can
yeah.
tell what delimiter I want.
Yeah. So
Just don't move to the new version.
So yeah, this is different from the Python split thing in that this is coming in from a reader, which may not all be arriving all at once. Whereas the Python split function, you have to have the entire string all available at once.
Sweet. So this adds in the scanner text thing, so you could just see that. That was the answer. Does this code make more sense now that we've talked about scanners? Because this is where we started out, right? We had net listen, and it gave us a listener right here, and then we defer the close, and then we accept a connection, and we launch handle, and we pass in the connection, we defer connections close, and then scanner, bufio new scanner, right? Takes a reader, there's a reader, gives us a scanner. We eternally are scanning, listening for stuff coming in now. And scanner get the text, whatever line came in, and then print that. Does it make more sense? Show of hands now that we kind of went over scanners. Could you just now just sit down at a terminal by yourself and let me retype this, I'll recreate that. Raise your hand. Yeah, me either. Kind of, a little bit. Maybe, That's why I love code samples. It's like if I know I could get, it's like Legos, right? Give me the blocks, I could build something, but don't ask me to go making plastic molds. I just want the blocks. Plastic molds, I don't know how to do that. Maybe someday. So here is the exercise. This exercise is awesome. And I hope you guys are starting to feel a little bit of enthusiasm because we're starting to break into uncharted waters for what we've been learning here at Fresno State with Go. And really cool uncharted waters. And also with a really good path and code samples, right? Even when I listen to Caleb, I watch his videos now and it's like, holy cow, that guy gives so much. And I'm going to give you he'll give an 18-minute talk, and it's just a fire hose stream of information. And when I watch the video at home and put together the code samples, it takes me 3 hours, right, to put together the steps and understand, some of it. But this is one example. He's so he taught us everything that you just learned, and then he said, okay, so go recreate Redis. We're like, what? He's all Redis. You guys know Redis? And we're like, no. He's all Redis. It's like Memcache, It's well, you want us to recreate Memcache? What? He's all, you got everything you need. Just go do it. You just need to have a get, a set, and a delete command. And then it's like a map, and you just store everything in memory. Okay. And so here's the exercise. Create a simplified Redis clone which accepts get, set, and delete commands. Get key should write the value of key, followed by a new line. Set key value should set the value of key. And del key should remove the value. Data should be stored in memory. Okay, well that is a little easier to wrap my head around. But how do we go from this, right? How do we go from this to being able to store things and retrieve things? On my own, I can't do it. but with somebody guiding me, cool. So this is the exercise. You will have to do the exercise. I'm giving you all of the code, right? So maybe probably what this will be is a retyping exercise. Retype it. But make sure you understand everything that's happening. And if you don't understand what's happening, look it up in the docs. And if you still don't understand what's happening, come back in and be like, okay, let's talk about that. I didn't get this one part. So, but just by retyping it and striving for understanding what's happening in each one, that's going to help reinforce and help you learn, these design patterns. So I broke this down into steps, and if you go into GitHub, you'll see under 41 TCP, we have 05 Redis clone, and we have I01, 02, 03, 4, 5, and 6. When you see an I in my code, that means it's an iteration. So here's iteration 1, And then iteration 2 means I'm building on it. And then iteration 3 means, okay, I'm building on it more, so forth. If you see a V, it means here's like one version, here's another version. Like maybe this is my take, and maybe this was Caleb's take, and then maybe that was Daniel's take. So there's places where I have like 3 versions. There are 3 different ways you could have done the same thing. When you see the I, it means, hey, I'm building on each one. So here is basically we started with main. We create a listener. We defer the close. We accept the connection. We pass connection into handle. We defer our connection close. We do bufio new scanner, and we get our scanner, and then we scan, and then liner scan text, right? So we get the line of text, and then we print that. That's what we already have. And so when we run this, we go over here to this one, and we say, okay, I want to connect to this whatever location through telnet, and then I type in echo, boom, echo shows up over here. And I type here, someone dialing in, it shows up where it's running, and same thing shows up over here where it's running, right? On the server, the TCP server. So this is the client, this is the server, right? The client is typing stuff, the server's receiving it, printing it out on the server. So that's all what we already know. So let's build on that. So that's iteration 1, the starting point. So the next thing we're going to do is we're going to change our handle func. So bufio scanner connection gives us a new scanner, and then scanner scan, and then line scanner text. Was that the same? Line scanner text, that's the same. But instead of format print line, which is what we had here, now we have line scanner text, and we have strings fields line, right? And that gives me all the fields. So this is another way that we can break things up by words. And we're doing it this way as opposed to using like, hey, scanner split, and then, bufio split on words or whatever that other one was. We're doing it here with fields because we are looping over every line, and then as we loop over every line, we get that line, and we want to break it up into words. So we want to have a line and then work with the words inside that line. So if the length of the fields is less than 1, jump out, right? Whatever, if it's less than 1, there's nothing there, 0. There's no words there. And if it's greater than that, there's words there. Switch, we're going to do a switch, and for that, we're getting an index here. So for the first entry in the index, so for the first word in our fields, so the first word from this line, right? If it's get, set, or del, we're going to run some logic. Cool! I can totally see how I can now start, all right, I'm going to start doing my get, set, and del, right? And then the default is just, hey, you didn't use get, set, and del as your first word, so invalid command, right? And so when I come here and I connect as a client, and I go to this location, I say set, favorite chocolate. Well, set is my first word, right? And so it goes there, and then that's it. It's done, right? It doesn't run any code, so set, that's it. And then when I type in nothing as the client, it comes here and says nothing, nothing, nothing. That's none of the cases, default. And it says invalid command, nothing. Invalid command, nothing, and it writes it to the connection. So write string writes to a writer, right? And the connection is a reader-writer, so it writes to that writer. It's sending that back to the client, so I get invalid command coming back to the client. And we have this printed out, comma, the next argument, invalid command, that, and a new line. Wow! Cool! I've started to build Redis, and I'm doing it with TCP. Now here's a question for you. Is this connection, like TCP is like the constant connection, right? It's not like break the connection after each request, right?
Yeah.
So I start this connection as a client, and then this connection between the client and the server is just always open, and we're connected.
Yeah.
It's like a phone, right?
Yeah.
That's cool. Would you call that a WebSocket? Am I coming in through a WebSocket here?
No, WebSockets is basically JavaScript's UDP or JavaScript's TCP connection back to somewhere else. Since normally on JavaScript you can't get a TCP connection on a web browser, you got to go through Ajax or something else with HTTP. WebSockets is the way to ask your browser, give me just like a plain TCP connection.
And you do that through JavaScript?
Yeah. So then a JavaScript server is a TCP connection, but it also has some additional handshake stuff it has to do with the web browser to make sure, confirm this is designed for connecting with a WebSocket.
Thank you, Stack. You're awesome, dude. All right, so here's the next iteration, right? Oh, let's make a map so we can store stuff, because we're going to set, delete, and get, right? We got to store it somewhere, and we're just storing it in memory, so let's create a map. And so the variable will be data, and we're setting it equal to, we're making a map, and the key is going to be a string, and the value is going to be a string. And so now we can come down here and fill out get and set. And so, if the first word, switch on the first word that comes in from the client. If it's get, then the key is going to be that next argument that the client passed in. The first word will be get, the next one will be the key, and then the value will be data key. We're going to store data key. Let me make sure I'm right. Data key will be value. Where's value? Get key. Where did I put value?
So
value is equal to data key.
Creating value.
That is equal to data key. I just hit a wall.
Yeah, you're going back up into your map and getting whatever's at.
Oh, I'm thinking this is set.
Yeah.
All right. So get means, hey, go get the value there, and then I'm going to print out the value. Thank you. And then here's set. This is the one. This, logically in my head, that should be up there first, but whatever. I didn't write this code. I rewrote it. If length of your words coming in is not equal to 3, right? Then you need your first word, which is get, set, or del, and then you need your second word, which is your key, and then you need your third word of value. So if it's not equal to 3, then we write to the connection expected value, right? So that's not necessarily the most logical thing. So what if it was 4, and but that wouldn't make sense either. So maybe we could have a better message there. So our key is going to be the second word, and then our value is going to be the third word, and then we're going to set our value equal to set the key equal to the value, right, in our map. And then so when we run this, log in as the client or connect as the client, and set favorite chocolate, and then get favorite, and it prints back chocolate, right? Prints back chocolate. Whoa! I feel like I'm in kindergarten for web programming. Like this is like really complex and at the same time really basic, But it's also kind of cool and it's really low level. It's like right to the metal. This isn't like, this is my analogy that I just came up with in the last week. When I learned web programming, it's kind of like the auto industry. Like if you learned like how to work on cars when the auto industry first started, you'd be like, no problem. I could totally understand a Model T. There's your cylinders and, like I could wrap my head around that. But just as cars, like over time, have brought in a lot more experts and become way complex. Like you open the hood of your car right now, and you're like, I have no idea what's going on in there, right? Like I feel like that's what's happened to web programming. It's like you open the hood on it now, and it's like, whoa, it became way more complex. This is no longer the Model T days, right? But this is like right down to the metal, a lot closer to the metal of like zeros and ones and what's happening. This isn't Cold Fusion or PHP. So here we have, we add delete. And so, again, we get our key and then we just delete whatever that entry was. So set favorite chocolate, get favorite gives us chocolate, delete favorite gets rid of it, and then when I say get favorite again, nothing's there. Whoa!
Delete's a function that takes in any map as the first argument and the key, the second argument, and just gets rid of it from the map. And just like most Go things, there is no undefined value. So if you try to get something that doesn't have a key, get a key that doesn't exist, it just gives you an empty value, zero value, which in this case our map is values are strings, so it gives an empty string.
I really appreciate your contributions. That's like, I think this works really well, like the dialogue. I like it. Then there's less pressure on me to keep the entire show rolling. So learn some cool things. You saw that Redis example. And the next thing we're going to look at is package strings. And because we saw a couple things going on with strings, and so let's just make sure that we look at the documentation and commit to our own heads how that's working. And so package strings implement simple functions to manipulate UTF-8 encoded strings. There is a great video on UTF-8, and I recommend you watch it. And it's computer file, and the video is, no, those are my passwords. I don't want to show you that. Wrong one. I think I just gave people information they could hack me with. So here it is, computer file, UTF-8, and it's right there. So maybe at the end of class we'll take the last 10 minutes and then watch this. But a great video, and just YouTube computer file UTF-8 if you're watching this online, because I can't show you the video if you're watching it online. So we saw package new strings, and we saw a new reader, which takes a string and turns it into a reader. So what do you call that, a wrapper function?
Kind of, almost.
Kind of, almost.
It's going to wrap the string. It's going to wrap a reader around the string.
Yeah.
So.
And then fields, we saw fields, right? And fields splits the string S around each instance one or more consecutive white space characters, right? So that just gives us all the words out of a field. All right, cool. So and returns a slice of strings. And then they have an example here. Printf fields are %q, right? So format printing is what printf means. And here, and then we have our formatting verb right there, %q. I'm not sure what %q means. And then strings.fields, and so we're calling that, and we're passing in this to that q right there, and it takes out all the white spaces and gives us back a slice of strings with foo, bar, and baz, right? And we can look up that formatting verb at godoc.org, format, and we can look for %q, and a single quoted character literal safely escape with Go syntax.
Doesn't quite make sense.
Yeah. I would have maybe gone with %v, which is like just give me the default for whatever I pass in. %v is somewhere in here. I don't know where it went.
Yeah, V was in the very top. But where's that other %q for?
Oh, double quoted string safely escape with Go syntax. There we go.
That's string and slice of bytes.
And slice of bytes.
So %q's got two options. Okay. And %v is at the very top.
Is it? Or is it?
Very first
There's
item.
another %v that gives us %v. Oh, here it is. The default format for %v. And then it'd give you all those, depending upon what you're doing. Okay. Thank you. View, present. So continuing with this example, right? We added in the delete thing. Here's our func main, which calls handle. This is the problem with this code, is it only handles one connection at a time. Could we make it concurrent? How? What are the considerations? Ooh. Dang. I was like so proud of myself. I thought we had like the working bomb, and no, you're in kindergarten. Let's go up to first grade. And that brings us into atomicity. I don't even know how to say that. Atomic, mutexes, and concurrency. How many people know atomic? Like you've heard of atomic, and you're like, oh, I know atomic. All right, explain it. What's atomic?
Right now we did it last.
All right, explain it. What's atomic?
Atomic refers to a variable. You can have atomic variables, and that just means only one thread can access that variable. So if you try to access an atomic variable, it will first check if another thread has ownership of that variable at the moment. If it does, then the thread will sleep and wait until the other thread that is owning it releases ownership of it, and then the first thread is able to access either to get the value or to modify it. I think.
Dude, that was awesome. I'd so high-five you if you're right next to me. That was like a great description. I couldn't have said that. That's why I asked you to say it.
Yeah, that's usually more explicitly done with mutexes. Atomicity usually is a bit more lower level. It can generally mean something that the processor can only do one at a time. So atomicity for variables is usually done for like ++, adding one to a variable. A non-atomic variable, you got the chance of reading it, adding one, and writing to it, but something happens in the middle between the reading and adding. Whereas if it's atomic, it can do the read and write all in one step, and so there's no chance of another thread interfering in the middle.
Yeah, so two really great definitions, and I just want to reiterate my understanding back in case people watching video online weren't able to hear the first one. But an atomic, if you have an atomic variable and there's multiple threads running, when that variable needs to be accessed by a thread, then only that thread can access that variable while it's accessing it. And when it's done accessing it, then that variable is accessible for other threads to access it if they want to access it. So it's a way you could sort of, I've got something I need to be thread safe, meaning I won't get, what do they call that when you overwrite stuff?
A race condition?
Yeah, I'm not sure if that's the right phrase, which is why it didn't popped ahead for me. But anyhow, you don't get those read-write, overwrite things. So anyhow, that's how atomic works. Okay, mutex. How many people worked with? How many people know what a mutex means? What does mutex mean? You know what mutex means?
Mutex are kind of blocks, so like only one entity can access that critical section at a time. So
Yeah.
1 or 0 something like that.
Yeah. So what's mutex? What's it? It's what do they call that when you like take two words and turn it into one? It's a abbreviation or an acronym or anagram. I don't know. What do you call that? Compound. My linguist. So that's what it is. It's a compound something or another. What do you call that when you have two words? What are the two words that are made out of mutexes here? Eunice, by the way, has his master's degree in linguistness? Linguistics, that's what you call it.
Mutual exclusion.
Yeah, mutual exclusion. So mutex stands for mutual exclusion, right? And then your definition was great, right? So it locks it so no other threads can access this chunk of code while one's, and then when that thread's done accessing it, it unlocks it. Yeah. And then concurrency, we'll look at that in a second. But here's...
So a mutex is usually provided by an atomic Boolean. If it's true, no one else can do anything, can grab it. If it's false, whatever variable can grab it, or whatever thread can grab it.
Yeah, this language starts at the intermediate level. That's it. Package atomic provides low-level atomic memory primitives useful for implementing synchronization algorithms. Cool. And so you want to see how it works? Check this out. So you could go to this GitHub, right? And this is the Bill Kennedy, who I think is awesome with Go. And you could go up here and you could just go search this repository if you don't know this already. And I could search in atomic. Right, and this is going to give you that same link, which I have right here. Actually, that looks slightly different, but gives you, let's see, it's same results, just different link. No, same link. That's cool. And then you could come in here and say, in all of Bill's training, how did he use atomic? Right. Well, there's the package. There's the package. There's the package. And here he's like atomic load in 64 and passes in an address for some variable read count on line 71. Okay, here he talks about it a little bit. Race conditions when two or more Go routines attempt to read and write to the same resource at the same time. So that's right. That would have been the right word. Race condition. Two or more Go routines attempt to read write to the same resource at the same time. Perfect. Race conditions can create bugs that totally appear random or can never surface as they corrupt data. Atomic functions and mutexes are a way to synchronize the access of shared resources between Go routines. When two or more Go routines attempt to access the same resource, we have a race condition. Atomic functions and mutexes can provide the support we need. All right, cool. Well, how do we use it? Here's his last example. Atomic, that it has to be an int32 or load int 64. I don't know. That's something about it I don't have straight yet. But and then so you can kind of see, okay, how did he use it? Right, and then down here, I don't understand this. I haven't figured that out. Yeah, but there's the resource. You can figure it out.
It's got the add int32 and such because most modern processors actually have a specific command that they can execute that's an atomic read, add the how much, and write as an atomic operation. So it doesn't even have to bother with any kind of locking or anything. It can just do it all in one step.
So whenever you need that letter of recommendation to work at Google, and then whenever you want to get together with the product manager of the Go language, I think I could arrange lunch. You just let me know, and we'll say, hey Jason, I got to introduce you to the next, Rob Pike, Ken Thompson, Robert Gressimer. They're going to be retiring, and I want to introduce you to my friend Stack. Sorry, I pump you up too much. It's embarrassing. You're like, dude, I go school these people. Lay off. They're my friends. No, but all joking aside, man. I'm totally impressed by how much you know. How old are you?
23.
Incredible. Package sync. Package sync provides basic synchronization primitives such as mutual exclusion locks. So we saw package atomic, and then sync gives us our mutexes. Right. Other than the once and wait group types, most are intended for use by low-level library routines. So we're not going to go into this a whole lot. Just kind of doing it let's become familiar with it. And then you could do the same thing with mutexes and see how mutexes were used in the training and how did he use mutexes. So just to take a quick gander at that, right? Var mutex, sync mutex, var mutex, sync mutex, mutex lock, right? So they were locking some code and, assume somewhere it gets unlocked. So you can see this code.
So while atomic stuff and mutexes are used a lot in other languages, Go doesn't really use them that much. In comparison, it's got its own methods for synchronizing.
And but one of the things Bill presented was a lot of what he sees is too many people using concurrency and Go routines and channels. And while those are useful, they get way overused in Go. And so Go is known for having an amazing ability to do concurrency with Go routines and channels. But don't forget about atomic and mutexes And he said like 90% of the time it goes atomic and mutex, and only 10% of the time goes with channels. And I don't know how Google's views on that, but
there are advantages to either way. Channels are easy to reason about, but then like the atomic add int 32 to just add a number to a variable, it's kind of a waste to put in all the code necessary for a channel to be able to do all that with another Go routine, as opposed to just you've already got a command that does it all in one step.
yeah. Yeah, cool. I'm glad you understand it. I'm still getting there. Concurrency versus parallelism. So this is like something that there's confusion about. How many people understand the difference before we get in? I just want to feel good that I'm adding value. All right. So concurrency is composition of independently executing processes, while parallelism is the simultaneous execution of computations. I kind of think about I could do things concurrently. Like I am now teaching class and drinking coffee, and I'm doing that concurrently, but I'm not doing it at the same time. Right? I'll teach a little bit, and then I'll drink coffee, and then I teach a little bit, and then I drink coffee, and then I teach a little bit, and I drink coffee, and then you guys are like, quit drinking coffee. You're talking too fast. Right? But that's concurrent. To do it in parallel, I'm teaching, I'm drinking coffee, I'm teaching, I'm drinking coffee, I'm teaching, that's parallel. Right? I'm concurrently doing it, I'm doing both things, and I'm doing it at the same time. So here's a little diagram of that. Concurrency, doing many things at once, but only one at a time. I go to A, I go to C, I go to B, I go to A, I go to B, I go to C. So this is like one thread, one CPU running three things, multitasking and just switching between them. Parallelism, I have 3 CPUs, and all 3 of those threads are running at the same time, concurrently and in parallel. And so here's another little diagram I grabbed off the web somewhere, and there's the place where I grabbed it. So the bottom one is concurrency without parallelism, and the top one's parallelism, concurrency with parallelism. Another way to look at the same thing. Continuing with our example and adding concurrency, oh dear God, help us. Ready? Here's our func main before we added concurrency, right? So we have, listen, get a listener, defer the close, accept it, get the connection, and then handle the connection, right? We send it to our function. And here we just add go handle. And then we have a couple arguments, right? So we're sending it to our connection, and we have something here called commands. Well, what's commands? Well, up here we got commands, calling equal make channel commands. So here we're making a channel. And a channel is a way you could communicate between routines. And so you could synchronize routines, and you could say, hey, this routine needs to stop here until this routine comes over here and receives something from it, and then everything can keep going, right? And so if we have one Go routine and it says I want to send something, it's going to wait right there holding the baton until somebody comes over here and takes the baton on another Go routine, right? And says, oh, okay, I've received that. And now this one can go, can walk off the track or do whatever. And now this one's holding whatever got sent over. If this one got down here and needed to receive something, it locks too, right? And it waits. Oh, I'm waiting for the baton. And then finally the baton gets there and it goes, right? So code will lock, and you'll get a blocking condition, if you're saying I want to receive something. We'll see that in a second. So there we go. We add a concurrency, and we didn't cover concurrency. So at this level, I don't expect you to be like, oh, I could totally implement this. Again, this is just sort of like let's become a little bit familiar with it, because as we become more advanced, we'll maybe want to add some concurrency into our stuff. And so you can look here, go by example, and see how Go routines work. And we created a struct of command type. So we created a command as our type, and it's the underlying type is a struct. Did I say that right? And it has fields, which is going to be a slice of strings, which would be like all of our words or whatever. And then we have a result, which is another channel, right, which holds strings. Interesting. And so here we're making a channel, and that channel takes this type command, which will have this stuff in it. And so that's called commands, that channel. And then we're saying go handle, and we pass this channel in here, and we send it also this connection. Like it gets kind of like, oh, okay, I'm starting to track stuff here. And then we also have a new function called Redis server, and we pass in that channel there, right? And so then here's the Redis server function, and we can see inside that we got our cases, get, set, delete, right? And we also have our default down here, so that's all familiar. And then we have now inside our data, which is our map, and then we have things here with these arrows. And so this is where we're putting something onto the channel. And so we're passing in here to Redis server channel command. And command, right, has a channel result. And so command right here is commands, range commands. So we loop over all of the whatever's coming in on this channel, and we hand it to CMD. And so we have access to CMD fields, and we also have access to CMD results, right, which is command fields results. Like I said, it gets complex. And I think this is kind of pointless for me to try to go through and just blabber about this stuff like quickly to you. But this is something you should look through and just like also sort of start to get your head around. I think it takes a little bit of time sitting with it. It's certainly taken me a little bit of time sitting with it. If it doesn't take you a little bit of time, awesome. I want to hire you too. Right? But here we're putting things onto the channel. So we take whatever's on the right and it says put it onto the channel. You could also have something where you have the channel over here and we're taking whatever's on the channel and taking it off. And so we're putting things on, to the channel in that channel there.
So result is a channel of strings, so you can put strings into it.
Yeah.
Whereas commands is a channel of commands, so it has commands going through it. Which is why we've got, when we get CMD out on line, was that 19? We've got
yeah, right there.
19. We're getting a CMD is of type command because it's coming from the channel that has commands in it.
It's kind of a trip because it's like a channel with a channel in it.
Yeah.
Dude, that's like, what's that movie where it's like the thing inside, that's like Inception. I think I asked that last week. What's that movie? So there's go by examples really good for looking at there, ranging over channels, and looking at how channels work, right? So we have go by example to show us go routines. We have go by example to show us channels. Those are those links right there, right? And then this just is reminding you that CMD field, CMD result comes from this struct right here, fields and result, right? And then here you can see, we're putting things onto a channel in all those locations, right? Putting things onto a channel. So we're taking data and we're putting it on that channel, and then we want that data to be received somewhere, right? So we're synchronizing different processes. And so here's this wall of code, dear God, right? Where all the code's right there. But as I start to do things like, hey, show me the commands channel, I want to see all the places that right here I make the channel command, and then I put it into Redis server, and then I also put it into handle. And how am I putting things onto that channel? Like that helps me sort of track what's happening, that slide. And then here, I've got result, and here's result, right? And so I'm making a channel of strings, and there's result. And, okay, so what's happening here? And like just trying to understand how I'm using the result channel. So that just takes a little bit of time to wrap your head around. You do not have to do this exercise building in all the channels. If you want to, great. But this is the exercise we saw at the beginning where I said, look, it's going to be a retyping exercise. Just understand each leg as you type it. You can take it up all the way through concurrency, which was like this thing right here where it's like I said, oh, wow, but this can only handle one connection at a time. If you feel like taking it all the way through concurrency, go for it. And you could come in here and you can watch Caleb's explanation, which after you retype it, you're like, okay, tracking. But at the same time, you'll be like, oh, I totally understood why 15 minutes of Caleb talking took 3 hours of Todd's time, right? To like, and there was days like that where Caleb would just like, that's, sometimes I have that experience with people who are really good with computers. It's like, dude, you start speaking machine language. Come back. I don't understand binary. So that's recreating that thing. And so the last thing to talk about, I think, is just like what is Redis, and a little bit of information on that and how Redis works since we kind of recreated that example. It's a NoSQL database, and all your data is stored in memory. So it's basically a map with key value pairs. It's really fast. And people use Redis like cache, right? So you use it in conjunction with a SQL Server often. And you load in what you're using into Redis, and it's super fast. But everything's backed up in the server. So it speeds up.
I thought the structure of what you were doing felt familiar. I was thinking, oh, this is kind of like a database.
Yeah.
Yeah. In-memory database, yeah.
In-memory database.
So very
And you
fast because of it.
You could look it up. You could look up Redis, online and read about it. It's an actual service. How do you scale this? So that's one of the things that Caleb talked about, like how do you scale Redis? It's an in-memory database. How do you scale it? That's my question to you. Do you scale vertically? Do you scale horizontally? What's that mean, vertical scaling? What's that mean, horizontal scaling? What are your thoughts? Distributed? So what's that mean to you, horizontal or vertical?
Vertical.
Okay. I don't know if I'm understanding what you're understanding, but the way Caleb explained it, my understanding of it, maybe this is what you're getting at, is vertical means, hey, we're just going to add more memory in one computer, right? and that would be vertical scaling. Horizontal scaling, which we'll see, and you'll when we talk about App Engine, and as we saw last year, horizontal scaling is like adding more machines. So instead of getting one machine and making it bigger, we're going to get a lot of machines, right? And we'll have 10,000 chickens instead of one ox. That famous Cray quote. Isn't that Cray?
I haven't heard it
Supercomputer guy?
before.
Oh my gosh, you guys haven't heard that one? Where have you been? 10,000
Learning coding.
chickens. Chicken fajitas instead of ox. Cray. I think that's it. Something like that. Seymour Cray. Here we go. Chicken. So this guy invented like Cray supercomputers, and his quote was, Cray had always resisted massively parallel solution to high-speed computing, offering a variety of reasons that it would never work, as well as one very fast processor. Ha-ha. Times have changed. He famously quipped, if you were plowing a field, which would you rather use, 2 strong oxen or 10,024 chickens? Right? I don't know. Like, I kind of get the analogy, but I think I'll stick with the oxen. I don't see how I'm going to hook up a plow to 1,024 chickens. Or each chicken's going to have a really small plow. And that's a funny image, actually. 10,024 chickens pulling around plows. I kind of like that image. That seems like a Far Side comic waiting to happen. All right?
I like how you use powers of 2 for his numbers.
Yeah. But that would be horizontal scaling, 10,024 chickens. Right? And vertical would be like, you go from having a dog to an ox. But anyhow, so horizontal, you add more computers and you partition your data with my phrase, hashing into buckets. And if you watch the video, you actually hear me say something along those lines. Oh, you hash it into buckets. And what that means is like every time data comes in, I hash that data, and then if it's for 2 computers, I divide it by 2. If it's for 10, I get the remainder after 10. And so after I hash whatever it is I want to store, if the hash value is 11 and I get the remainder of dividing by 10 modulus 10, I store that in computer 1. If it's 12, I store it in computer 2. If it's 73, since the remainder is 3, I store it in computer 3. If it's 134, since the remainder is 4, I store it in computer 4, so forth. If it's 1095, remainder is 5, I store it in computer 5, right? And then I know where my different data is stored, and I can horizontally scale that across multiple machines. And then access it.
That's cool.
Dude, so like this training this summer, I'm telling you, is like, whoa. Like, wow, you are really smart. And you're going, like, there was times when Caleb would be like, I can't help you. I don't know why you're so dumb. Like, he would literally stand over my shoulder and like, he wouldn't say that, but it's like, and I have those moments when I'm a teacher, I'm just like, I don't know why you don't understand what I'm saying. Right click, the right button on your mouse. Click the right button, Not the left one. You're still clicking the left one, the right one, right? But Caleb be like that. It's a reader and writer. You put in a reader-writer there. Why don't you see that? I'm like, I don't know. I must be an idiot. I'm new to it, man. I'm just figuring it out. But Caleb was like, had a really fast brain too. And he's been at this for 15 years, so it's second nature to him. So what happens if the power goes out? That's the next question, right? And so you could have a NoSQL database, very people. So this is the stuff we already talked about. So if the power goes out, whoa, what is that one? If the power goes out, you need to have a backup, right? And so this is a master slave. And so last night when I was looking for master slave, this is my process. I'm like, not that image. Not that image, but that's kind of interesting. What's going on there? Not that image, but that is wild. People used to actually sell shirts like that. Like, whoa, that was like the sexist 60s right there. A super gift for brides to be. What? So this is the image I'm looking for. Master slave. And so they store identical data. They're mirroring the data, right? So I'm taking my NoSQL database. I write it to my Redis. I write it to my master NoSQL. I write it to my master slave. And then if my master crashes, I have all the same data on the slave, which becomes the master, and then I just get a new drive, which then becomes the new slave, right? So that takes us into CAP theorem, which Caleb talked about. I don't know. I just thought I'd pass it on. You can look it up. But CAP theorem is like, about writing data, and you could have 2 of 3. You could have 2 of 3 of these things right here. You could have consistency, you could have availability, or you could have partition tolerance. You could have 2 or 3 of those. Right? And so when we're working in App Engine with NoSQL databases and horizontal scaling, which is what makes NoSQL databases and App Engine awesome, is it will scale. they talk about that, and you'll have eventual consistency with App Engine. So that's the one that we don't get. But that takes you back to CAP theorem. How many people have heard of CAP theorem? Yeah, one person. Like that's where I was like, wow,
The
okay.
2 out of 3 comes up a lot in computers. What is it? And other things too. Like what is it?
Like sleep,
on time, on
family,
budget, and-
programming. You can have 2 or 3, 2 out of 3. Which
So,
one?
And then I think the one I've heard the most is features, on time, and on budget. Pick 2 out of
Features
3.
on time, budget. Yeah, that's good. Exercise is modify echo so that it returns messages as ROT13. And so that example is also in the code, but you should know enough with your telnet servers to just like, okay, it's the exact same thing where we are echoing, the client sends a request in and we just print that, but before we print it, we just rotate all of that ROT13. And there's actually 3 versions of this code. You can look at TCP, I think I'm still in TCP, and ROT13, and you can see here I'm using the version, and there's Todd's take, there's Caleb's take, there's Daniel's take. And it goes like, simplest to understand, hard to understand. You just want to preview? No, you can look at it on your own. But that was like a really fun exercise, and it was pretty cool. And then there's an optional exercise, and you do not have to do this as homework, but if you feel so inspired and you're bored in the class and you just really want to kind of put the pedal to the metal and get stuff, create a chat room server. You've got everything you need to create a chat room server. Like Caleb gave this to us, and he said, and then like after 18, 20 minutes, he's like, okay, is everybody done? No! Haven't even started. Still trying to figure it out. Right? But, and then the next day he's like, so I think that exercise was a little bit hard for you guys. And so he walked us through and gave us the solution, and here's the chat server. So you can take a look at the solution for chat server. And so you can now, you now have the code and the resources to really understand this. Create a chat room server. Client can connect and send messages to the server. Those messages will be broadcast to any other concurrently connected client. Whoa. Concurrently connected client. All right, so I think at least getting 4.5 hours sleep results in a much better class. There's a fine balance between prepping and sleeping. So I hope you guys got some really good material. We got 5 minutes left, so I'm going to show you just the first 5 minutes of this UTF-8 video. Or do you have enough and you're like, no, don't give me more, I just want to keep what I got? See the video?
Yes.
Raise your hand. Don't give me more, raise your hand. All right, you got outvoted, sorry. So we're going to watch this video, and then we'll watch. I'll run it the whole time if you want to leave after 5 minutes.